So the last topic that I need to teach you for the SOL is called normal distribution. Normal distribution. And I'm definitely going to have to record this in at least 2 videos, hopefully not more than that. But I have to separate it into like some basic information, like what is the normal distribution, what is the normal distribution curve, what does it show you, et cetera, et cetera, et cetera. So that's why I have this diagram. And then I will actually show you what kind of questions you'll have to answer about it, and then how to do that with Desmos. Okay, so let's start with normal distribution. So normal distribution, or a normal distribution curve, looks like kind of like a bell. If you've ever heard of the bell curve, that's a normal distribution. What that means is that you have to be given data, okay, and the data is kind of spread out in a way that makes this this bell-shaped curve. Okay, so what you need to know about this curve is that the total area, okay, total area under the curve equals 1. And so if I turn that into percentages, total percentage, and you'll see what that means more in a minute, total percentage would be 100%. Okay? And so what I mean by that is, like I said, this curve represents a way to display data. And so 100% of the data is used to fill up this curve. Okay? Now, a couple of other things. The middle, the direct middle of the curve, is called, when you have data, that's where you put the mean. Okay, so that's where the mean goes, and we're going to use a mathematical symbol, a capital Greek letter M, called mu. All right, and that represents the mean. So the mean of your data goes in the middle, and the rest of the data is spread out around it. Okay. And then we have this thing called standard deviation, and that's how spread out the data is. Okay, that gives you an idea of how spread out the data is. And it uses the Greek letter, the lowercase Greek letter sigma. It kind of looks like, some students tend to call it an O with a hat. Okay, and real quick, just again, hopefully you remember the word mean. All right, is an average. Okay, mean is the average of all the data values, and sigma, or standard deviation, that measures how spread out, the data is around the mean. Okay, so on the normal distribution curve, you can show, I have some things marked here, you can show up to 3 standard deviations and account for almost 100% of the data. Okay, so if you know a standard deviation, you can move to this mark here by adding 1 standard deviation, or you can move back 1 mark by subtracting 1 standard deviation. Okay, you can move to the second mark by adding 2 standard deviations or subtracting 2 standard deviations. Or it's hard to see, but there is a little third mark right here. You can get to this third mark by adding 3 standard deviations or going backwards and subtracting 3 standard deviations. All right, so one thing I'm going to get you to do is I'm going to actually tell you the mean of some set of data, and I'm going to tell you the standard deviation, and you're going to have to fill the numbers in. Okay, you're going to have to actually put their values on a normal distribution curve. Now, this is just a generic normal distribution curve, but they can certainly look flatter, or maybe they can look tall and skinny. All right, but it's all about being symmetric, where the mean is in the middle. Okay, now to be more spread out like this, okay, you're going to have a bigger standard deviation, gives you more spread. Okay, it's going to look low, it's going to look a little flatter, and it's more spread out. But if you have a smaller standard deviation, that means your data is less spread out, so it's all going to be grouped together in the middle. All right, so there's going to be less spread, so it's going to look tall and skinny. And I say that because sometimes there's an SOL question that's just as easy as looking at a little diagram and saying which one has the bigger standard deviation or which one has the smaller standard deviation. Now, let's talk about percentages, okay? The mean is in the middle. So if the total is 100, and the mean is in the middle, all right, then this entire, ooh, that's really bad. This entire half would be 50%, right? And then this entire half would be another 50%. Would you agree with that? Okay, but we can break it down even smaller by knowing a little bit more information about normal distribution curves. All right, well, normal distribution curves have this thing that you can use to approximate percentages called the, oh, I spelled it wrong, the empirical rule. The empirical rule. And it can be used, again, like I said, to approximate some percentages. And so here's the rule. It's three numbers. It's 68, 95, 99.7. That's the rule. I know it's kind of weird that it's just three numbers, all right? But here's what it means. It means that 68% of the data lie within one standard deviation of the mean. Okay? 68% of your data lies within, that means forwards and backwards, within one standard deviation of the mean. Okay? And that's approximately. Within one standard deviation of the mean. Okay, so that means these two boxes here total 68%, right? But everything in this curve is symmetric. So if I cut that in half, then I can easily find that there's 34% in this section and 34% in this section. Okay, now the 95, that tells me how much is within two standard deviations. Okay, 95% is going to be within two standard deviations of the mean. So if that means the four middle boxes add up to be 95%. But the very middle, those two add up to be 68. So if I want to know what's left for these two, I do 95 minus 68, and then, which is 27, and then I split it in half, and I can get the percentage in this section and the percentage in this section. And then last but not least, well, I won't say last but not least, I guess, the empirical rule tells me that 99.7% of the data can be fit into the three standard deviations from the mean. All right, but the middle four already took up 95%. So I say 99.7 minus 95, which is 4.7, and then I have to split that in half between these two little sections. So each one of these has 2.35%. But then wait, I said the whole thing adds up to be 100, and I've only done 99.7, which means I have 0.3% to split between this little tiny section here and this little tiny section here, 0.15%. Okay, so the empirical rule can help me remember that. These are approximations. If you want exact percentages, that's when Desmos comes in to play. Okay, now we're almost done labeling our diagram. The other thing that you are going to have to, or that we're going to learn about, is this thing called, let me find a different color. This thing called Z-score. Okay, now Z-score is basically a way to, in a sense, I guess, figure out your location on like the number line of a normal distribution. Okay, it kind of helps you figure out your location. And it basically tells you how many standard deviations you are from the mean. Okay, so there's a formula for finding z-scores, and that's one thing that we're going to do later, is actually calculate z-scores. And in order to do that, you need a value minus the mean divided by the standard deviation. But again, these values are going to be numbers that basically tell you how far you are from the mean. So if you're exactly on the mean, then your z-score is 0. You are nowhere, you have not moved any distance from the mean. Okay? As you work your way forward, every standard deviation forward, you go up by 1. So when you add exactly 1 standard deviation, your z-score is 1. When you have exactly 2, when you are exactly 2 standard deviations from the mean, your z-score is 2. When you are exactly 3 standard deviations from the mean, your z-score is 3. So basically, it's like turning the mean into a number line, and then all the values. All right, the mean and the standard deviation, it's turning them into a number line. If I go backwards, I just get negative z-score values. I get negative z-score values. All right, and so if I said, let's say I had a z-score of negative 2.5, then I would fall somewhere right here, okay, on the normal curve. All right, and hopefully that'll make more sense when we do some examples. So I know right now that doesn't mean much, but those are things that you are going to need to be familiar with when you take the SOL. So the area under the curve is 100%, but when we talk about area, we're gonna talk about it in terms of decimals, okay? And so that's why the total area is 1. All we would be doing is converting percentages back to decimals. You can approximate those percentages using this thing called the empirical rule. Sorry, I didn't actually finish writing that. Okay, the empirical rule, and those are 3 numbers, 68, 95, 99.7, but you do need to be familiar with what those mean, okay? And then the whole idea of the curve is labeled with the mean in the middle, and then each mark forward is a standard deviation, and each mark backwards is a standard deviation. And then then you can convert those to z-scores, okay? All right, so that's gonna be it for my first video, and you'll definitely wanna have that handy as we actually answer some questions about normal distribution.